Hello guys, welcome back to Maths on African Motives. Still working on our revisions for Mathematics N4. We are going to be working on the final revisions as we are preparing now for the exams that are ahead of time. So we just want to see typical questions and what exactly are you expected to understand on those typical questions for any also of the similar questions that you're going to have. So we have this part. If you have to check, we have got the part of sketching of graphs, the solving of exponential equation, the change of subject, which is from our logarithms, and also the word problems that we have here, the word problem. So that is it, 20 marks for that. So we shall see how we're supposed to attempt these typical questions. So the first question that we are given is question 2.1, where we are given to sketch the graph of y is equal to 1/4 cos x, whereby x is given that it's greater than or equal to 0, but less than or equal to 2 pi. So this is the interval that we are given that is affecting the values of x. And if you're given this pi, it means these values, they are considered in radians. So as we know that from our conversion, actually, if you're talking about 2 pi, we are talking about 360 degrees. Remember that pi is equal to 180 degrees, and 2 pi is the same as 360 degrees. If you multiply by 2, you multiply by 2 here. So that would be 360 degrees. So in terms of the degrees, we know that this is 360 degrees, but it's supposed to be given in radians as we are given our interval in radians. And also, if we are to check from our graphs, guys, we also understand that this 1/4 here is simply representing how our graph should be taken from the maximum to the minimum value, which is the amplitude of the graph. So if we are to have our graph, we know that in a normal separation of values, as we separate our values for x, which is talking about the interval that we are given, we are going to have the step that we are going to consider, which is a separation of the values of x. And we know that in terms of degrees, this is supposed to be 90 degrees. We separate our angles. We are talking about 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees. This is what we are used to if we are dealing with degrees. But here we are given in radians. So that means we are supposed to make a conversion of these angles that are in degrees to be in radians. So that is the scenario that you're going to make, or you can simply have your angles in degrees, but since you are given this interval in radians, it means also on your graph, you are supposed to have your values in radians as they are. All right, so how are we going to convert that? It's either you are going to use the first one that you are given here, that is pi, it's 180, or you use 2 pi is 360. It's one and the same thing that we see here. So meaning to say, we can use any of these two that we are given to represent 0. So 0 is just same as 0. So if we move on to 90 degrees, all right, let me just have my table here, having the values of x and the values of y in this case. All right, so I'm just going to have a table showing the values of x and the values of y corresponding to each other. So like I said, we're supposed to have this as 0, 90, and so on. So this one, 0 degrees in radians is just as 0, this one. So we're going to have as 0. And we move on to 90 degrees. So you just ask yourself, if pi is equal to 180 degrees, what about 90 degrees? How am I going to convert this to radians? So to convert to radians, you simply have to divide the angle that you want to convert to radians by 180. So it's 90 over 180 times pi. So that is how you convert this. 90 over 180 times pi, which is going to be 1/2 pi, or you can just write as pi over 2. So that means 90 degrees is same as pi over 2. All right, then we've got 180. Remember, 180 represents pi. So here we have got a pi for 180. Then 270, we've got the same thing. Just like what we did on 90 degrees, we are going to have this as 270. So if we divide 270 divide by 180, that will be 3/2. So we're going to have 3/2 pi, or 3 pi over 2. All right, so this one is going to give us 3/2 pi, or 3 pi over 2. Then we move on to 360 degrees, which you say 360 degrees is equal to 2 pi. So this one, we already know that this is 2 pi. So that is the interval that we're going to consider from 0 to 2 pi, considering in radians, which are the same angles that we are used to in degrees: 0 degrees, 90 degrees, pi, which is 180 degrees, 3/2 pi, which is 270 degrees, and this being 360 degrees. We are used to this part being in what? In degrees, having a step of a step of 90 degrees from the 0 point, from 0 having 90 separated in between. That is what we have, and that is what we are used to. So if we are to have this table in radians, it means we are simply going to sketch our graph as we are given. So we're just going to have our values, corresponding values of y, which meaning to say our calculator has to be in radians in this case. With this indication that we have, we can simply have our calculator. So this one, it's up to you on the calculator part, like I said, because we've got two things to consider: the degrees and also the radians. So if you are to have your calculator like this one, it's already in radians. If you check here, there's an arrow here for radians. So to do that, it's just shift mod. Then you check here, the 4 is for radians, 3 is for degrees. All right. So to be in radians, we are going to have this as a 4. So that means we are going to simply have 1/4 cos x, which is our x, it's a 0 there. So it's going to be 1/4 like this, which is the cosine of 0 in radians. We are going to have our answer as 1/4, which is the corresponding value that we are having for y in this case, which is 1/4, or as a decimal, it's 0.25. All right. So this is going to be 0.25 as a decimal, or 1/4. All right, then we move on to pi/2, which is in radians. So we are going to just have here as pi/2. So that's pi here over 2 like this, which is going to give us a 0. All right, so that is going to give us a 0. The corresponding value that we have here is a 0. So it is the same scenario, even if we had to work this with our calculator being in degrees. Let's say we have to change our calculator to be in degrees. Here we have this as a 3. Our calculator is in degrees, so that means I'm not going to use pi/2, but I'm going to use the angle in degrees corresponding to pi/2, which is what? Which is 90. So you can simply use your calculator as usual in degrees. Still, we are going to have the same thing as 0 in this case, which is the same thing if we are to move to this angle, which is pi, which is 180 degrees like this. We are going to have our answer as -1/4, which is -0.25. It is the same answer that we are supposed to obtain if we use pi, but being in radians. If we change this to radians, which is 4, and we use a pi in this case here, we are going to have this as a pi like this. So we're going to have -1/4, which is the same answer that we got. So this is simply one and the same thing. If you use your calculator in radians, make sure that you are having this part of the radians of the pi. But for the simplification part, you can just, if you are used to your degrees, you can just use your calculator in degrees, knowing that 270 represents 3 pi/2. That is the situation that you're going to have there, which is just one and the same thing. All right. So the next one there is 3/2 pi. All right. So that's over 2 like this in radians. That is going to give us a 0 in this case. And the last one is 2 pi. So this is going to be 2 pi like this, which is going to give us 1/4, which is same as 0.25. All right, so these are the values that we are obtaining from our calculator corresponding to the x values. We've got the y values. So these are the values that we are going to have on our sketch in this case, as we are given our interval from 0 to 2 pi. So we can just have our sketch here. Remember the graph, of course, also the shape and so on. You must keep that in mind. Yes, you are having your sketch here, but also keep in mind of the graph that you are going to have at the end. All right. So this is, you can have 0 here, pi/2. Let's say this is where we have our pi/2. Then we've got pi, 3/2 pi. All right, then we've got 2 pi for 360 degrees. All right, so these values, they are corresponding. Let's say this is where we have our 0.25. Let's say this is where we have 0.25. depending with your values, maybe 1 is on top there, negative 0.25 as well. Maybe we've got negative 0.25 this side. So as you are to sketch this graph, you're supposed to mark the points corresponding to what we have in this case. Like we've got 0 versus 0.25. So that's a 0 here versus 0.25, which is this point. You can mark this point. Pi over 2, it's versus 0. Pi over 2 versus 0. You mark the point. Then we've got pi and negative 0.25. So this is pi, negative 0.25 down here. Where these two meet, you mark a point. 3 over 2 pi versus 0, you mark your point. 2 pi versus 0.25, which is on top here. All right, so these are the points that are very, very important to indicate on your sketch as you are going to join these points from the first point to the last point. All right, so you're going to have a continuation of the points up to the last point in this case like this. All right. So this is the graph of y is equal to 1 over 4, the cos of x. So as you can see, it has the maximum value corresponding there at 0.25, the minimum value corresponding at negative 0.25, having a step of pi over 2, which is 90 degrees separated up to 2 pi. So with this, we can obtain the full marks and also indicate your x and y values, on the x-axis and also your y-axis. So each and every graph that you have for a trigonometry, just try by all means to have a sketch the same way that I'm having. You have a table like this, whether it's the graph of tan or is the graph of sine. You are given that y is equal to the, maybe it's negative 2 sine of x. Just try by all means to have a table like this of the x values corresponding to the y values. Then you mark those points like that. You won't even go wrong for this trigonometric type of a graph that you're going to have. All right, 2.2, we are given again to sketch x squared plus 3y squared, which is equal to 3. What type of a graph are we actually having in this case? All right, that's 2.21. So let us just try to have it here. So we are given to sketch the graph of x squared plus 3y squared, which is equal to 3 like that. Okay, there is a great confusion that we have in the sketching of this type of a graph, which is an ellipse and also a circle. These two, they are similar to each other. If you check for the equation of a circle, you are going to see that you have, or you must have, same values. If this was a 3, here you must also have a 3, such that we're gonna have this as 3x squared plus 3y squared is equal to 3. So that if I divide by 3 here, I'm going to be left with x squared plus y squared is equal to 1. Once here we have got the same value of x, the same coefficient of x squared and the same coefficient of y squared, it means that's a circle. But the moment these numbers, they are different, to say here there is a 1, here there is a 3, or maybe here there is a 2, here there is a 3. Once these two numbers, they are different, you are going to have an ellipse there. And also, if this is a negative on this part, you're going to have a condition whereby it will be not joining each other. You're going to have a separated graph of this nature, one on the other side, one on the other side, when it is having a negative like this. But when you're having a positive, it is going to be a complete ellipse. As we know, the shape of an ellipse is just similar to that of a circle, just of this nature here. So it's going to be something of this nature, or we can have our ellipse in this nature. It's not a circle the way that we see a circle. No, it's actually different. So that is what we are going to expect to have at the end. So how are we going to have this now at the end? We can just use the same concept as normal graphs to find the x and y intercept. This is an algebraic graph where we have got x and y like this. We do not have sine or cos, whereby we need to have our angles 0, 90, and so on. Here we focus with the x-intercept and the y-intercept. So as we know that for the x-intercept, it must be on a condition that y is equal to 0. So if this part of y is equal to this y here is equal to, it means we've got 0 squared times 3, which is a 0 there. So we're going to have this whole part being equal to 0, all right? So that's at the end, we're going to be left with x squared is equal to 3. So to find the x values, we're going to introduce the square root since we've got a square. So that's the square root of any number. Remember, it's a plus or minus. So we're going to have the plus or minus square root of 3 in this case, or you can even write it as a decimal if you want. All right. Then we move on to the y-intercept. Just like for the x-intercept, we're going to have our y-intercept on a condition that x must be equal to 0. So if x is equal to 0, we're going to have 0 squared, and this whole part must be equal to 0. So that means we are going to be left with these two. That is 3y squared is equal to 3. All right. Divide by 3, divide by 3 here. So that means y squared will be equal to positive 1. All right. To determine the value of y, introduce the square root, of which we know that the square root of any number is a plus or minus. And for 3, all right, this is square root of 3 there, or not 3. This is square root of 3, all right? But this one, the square root of 1 gives us 1 there, that's plus or minus 1, all right? But the square root of 3 cannot be simplified. Sorry for that, I thought we've got a square root. We've got a square root there. Square root of what? The square root of 3. So with these values that we have, the x value here, the y value here, we are going to use this now to have our sketch, and also bearing in mind the type of graph that you're going to have. It's very, very useful for you to know the type of graph that you're going to have before you even draw the graph or sketch the graph, because it must not be surprised to see the shape that you're going to have. You must know the graph that you are having, the shape, how it is supposed to be drawn or given. All right, so here we know that, as we explained, an ellipse, you can expect it to be of this way, or we can expect to this, or it's not a circle that we have at the end. All right. So let us check our intercepts. We have got the x-intercept at square root of 3, which is actually decimal square root of 3. And we also have a positive 1. All right. If you are to check the square root of 3, let us confirm, is it greater than 1? Or it's because you have to compare which side is going to be bigger in this case. All right. So that's the square root of 3 in this case is equal to 1,73 and so on and so on. So as you can see, this value is greater than 1. So the x values, they are going to be a little bigger to the y values. So let's say we've got negative square root of 3 here, and we also have the positive square root of 3 here. On top, we are going to have positive 1. As we compared that, the square root of 3 is greater than this one. We got something like 1,732. It's bigger than 1. So as you are going to mark the y values, you must mark your values a little bit below these values, because we've got -3. The distance may be somewhere here. We're going to have a 1, and somewhere here we are going to have a -1. So these are the y values, or the y-intercept at +1 and -1. Then you can simply join your graph in this case. All right, so that is going to be of this nature, remembering the shape of the graph and so on and so on. All right, so that's something of this nature. All right, so that's our ellipse in this case, whereby we're given x² equation of our graph. That's x² plus 3y² is equal to 0. So that's plus 3y², which is equal to 3, not equal to 0, but equal to 3. So that is how we are supposed to have our graph at the end. So as you can see, you just have to be very careful how you are given your graph. If it was a circle, like I said, we must have same values. If it is 2x² plus, we must also have a 2 here, maybe it's equal to 4, whatever that you're given, so that if you divide by this, you are going to have something of x² plus y² is equal to 2, whereby we can have our circle from the x coordinates, the y coordinates being, the y-intercept being at plus or minus the square root of 2. In this case, the x-intercept being at plus or minus square root of 2. You have same values for the y-intercept, and for the x-intercept, they will be the same. But the moment you see that the y value is at maybe 3, the x values, maybe they are at plus or minus 2,5. They are no longer the same. It's no longer a circle. We are now talking about what? An ellipse. So that is the difference of these two graphs. So you just have to be careful as you are revising towards exams, the difference between these two types of graphs. And also, if you check for the calculation purposes, it is the same. How you determine the x-intercepts and the y-intercept for both graphs is the same. Only that you will see that these two values, they'll be different. For an ellipse, they'll be the same. For a circle, that is another thing that you can use to confirm that this is a circle. All right, 2.22, they're now saying, is this graph of x squared plus 3y squared is equal to 3 in question 2.21 asymmetrical about the x-axis? All right, if we are saying it's asymmetrical, it means it's not symmetrical to the x-axis. But this graph, as we can see, it is symmetrical to the x-axis. This is the x-axis. To be symmetrical is that if you see this half here on top is the same as this half below. So if you draw a line like this around the x-axis, you see that this half on top can cover up this half down, that it closes without leaving any part or any remaining part. This piece that we see here, it closes with this piece here. So it means it is symmetrical. Also, it is symmetrical about the y-axis because the half that we see here and the half that we see on the other side, they are the same. So it closes without leaving any part that is not affected. Every part is going to be covered up symmetrically. So meaning to say this is a straight no because they are saying it's asymmetrical, which this one, it's what? It's symmetrical. So that means there it's a no. It is actually symmetrical. It is symmetrical in this case, all right? It is symmetrical about the x-axis. About the x-axis. So like I said, also it is symmetrical about the y-axis. Okay, so that was it. Question 2.3, sketch the graph of y is equal to 3 to the exponent of negative x. So there we are referring to an exponential function. It's either you just have to know the type of the graph that you are going to draw at the end. Remember, I talked about this on our functions, that if you're given y is equal to a to the exponent of bx like this, or you can just have it as kx so that we properly understand like this. All right, this is an exponential function that you're simply going to have if this k is being a positive, if k is greater than 0, that is being a positive, we are going to see our graph this way. All right, that is how our graph is going to be taken, passing through the y-intercept at 0.1. All right, if here we do not have a number that is affecting, it means it is going to pass the y-intercept at 1. This is a condition when k is a positive, it's greater than 0. It means we are talking about what? Positive values. But if this k is less than 0, whereby we are talking or referring about negative values, we are going to see the sketch of the same function, which is an exponential function, in this way this time. So it is going to be having positive values, then it decreases with the x values. All right, so it is going to be decreasing with the x values. So this is the same graph that we are seeing here, because we are given this as a negative exponent 3 to the exponent of what? Of negative x. Or you can just have a table to draw this graph, but you can simply have from this understanding that I'm explaining here. So that means the graph of y is equal to 3 to the exponent of negative x, in this case at the end, is going to be like this. Since we have got a negative on the x value here, our graph is going to be positive, more positive, then it decreases with the x values increasing. So y will be decreasing, but x values will be increasing. So that is something of this nature. All right, so it will be tending as if it is to approach the 0 in the x-axis, but it won't approach the x-axis. All right, so on a condition that x is equal to 0 here, we're going to see 3 to the exponent of 0 gives us a 1. So that's why we see that always here we're going to have a 1, as long we do not have a number like 2 times 3 to the exponent of x or any number multiplying. This graph is going to pass through the point 1. All right, so that's the graph of y is equal to 3 to the exponent of negative x. Or you can just substitute the x values. Maybe we've got 1, 2, 3, 4, negative 1, negative 2, negative 3, and see how the graph is increasing or decreasing. By having that on your table, you can see that as the negative values of x are going this side, we are going to have a sharp increase in the y values. But as we go to the positive, we shall have also a sharp decrease in the y values. So that is the scenario of your graph. You can also prove that using the calculator, as I mentioned. All right, on question 2.4, we have got an equation that we're supposed to solve. That's an exponential equation that we have, and we are given this as 7 to the exponent of x plus 2 must be equal to 1 over 5 to the exponent of x minus 1. Maybe you are avoiding working with fractions. You're working with 1 over 5. You want to avoid working with a fraction. You can just rewrite this as 5 to the exponent of negative 1. Remember, 1 over 5 is same as 5 to the exponent of negative 1. But there, we are going to affect this with the exponent that we have, which is of x minus 1. So that means the negative 1 is going to multiply everything. That's 5 to the exponent negative 1 times x, which is negative x, negative 1 times negative 1, which is a positive 1. So that means you can rewrite this as 5 to the exponent of minus x plus 1. I'm not saying if you write this as it is as 1 over 5, you introduce your logarithms, a logarithm this side, a logarithm this side, you're not going to have the same answer. No, you are simply going to have the same answer. It's just a way that you properly understand. It's easier if I am working with whole numbers like this than working with fractions. It's easier to make mistakes there. But if working with whole numbers, it's going to be easier for us. So just introduce the logarithms both sides. That means we are going to drop the exponent that we have to multiply with the logarithm of 7 in this case. All right, so we're going to have x plus 2 into the logarithm of 7, that is ln 7 is equal to, we do the same thing, we drop the exponent, which is negative x plus 1. Whatever that you have, you multiply to the logarithm of 5, which is the ln of 5. Yes, I can use my calculator, find the value of ln 7, find the value of ln 5, which is fine. I can do that. But if I just want to obtain exact values, I want to avoid rounding off a lot of values as I am working out. So what can I do? I can just expand as it is. All right, with the ln of 7, if I multiply here, it's going to be x ln of 7 plus 2 times the ln of 7, which is 2 ln 7. This is equal to, you do the same thing, negative x times ln 5, which is negative x ln of 5. You do the same thing, 1 times ln 5 is supposed to be 1 ln 5. But as we know that this one here does not affect anything, so you can just write it as ln 5. So if you've got this, yes, you can use your calculator to use as a decimal, but you can avoid that. Work with exact values, and this gives us exact values at the end. As we're just going to see that we've got an x there. We also have x here, so you can collect our like terms. In this case, I can transpose the one that has got a negative so that it can become a positive on the left-hand side. So that's, I've got x ln of 7 plus x ln of 5, which is equal to, I have to transpose this part to the right-hand side because I do not have x on this part, right? So that means I'm going to start with the ln 5 that is already on the right-hand side. If I transpose the positive 2 ln 7 this side, it will be a negative. So I'm going to have negative 2 ln of 7. All right, so as you can see on the left-hand side, we've got x, and we also have x there. So you can factor out the x, which is common. If I factor out the x, I'm going to divide. So this x and this x will cancel. So that means here I'm going to remain with a ln of 7 plus x ln 5 divided by x, x and x cancels. We remain with a ln of 5. All right, so this is equal to the ln of 5 minus 2 the ln of 7. So that means I can properly determine my x if I divide by this bracket throughout. So I'm just going to divide by the ln of 7 plus the ln of 5. And this side, I'm going to do the same, the ln of 7 plus the ln of 5 in this case, all right? So that means I can cancel this part, have the x value in exact form. All right, so, but as a decimal, I'm going to simplify this from the calculator, which means we're going to have something of this nature. All right, so let's just save our calculator here. So we're going to have a fraction that is the ln of 5 close the bracket minus 2 ln 7 right? So close the bracket again, all right, over the ln of 7. So this is the ln of 7 plus the ln of 5. And also the other question is, if my calculator is in radians, am I going to obtain the same answer? All right, so the issue of radians does not affect values such as log, ln, or any other part of numbers except for the trigonometric values. As long we are talking about the sine, the cos, the tan, the cot, those values that are under trigonometry are the ones that are affected by radians, not anything else. So even if your calculator is in radians, this does not affect your answer, all right? So that is going to give us negative 0.6419 and so on. So you can even round off to 3 decimal place. That's a shift set up. You go to the fix on this number 6 here, then to 3 decimal place, that's just press 3 here. All right, so you've got your answer to 3 decimal place, which is negative 0.642. So that would be negative 0.642 in this case. All right, so that is the x value that we are going to have corresponding to the given exponential equation that we had. So like I said, you can even work with the fraction as it is. Maybe you do not want to work with the whole number. You just want to work with the question as it was in the original case. You can also do that. You must have the same answer as this one. All right, so let us check now question 2.5, where we are given in this case, we have got a logarithm. All right, given that L is equal to, that's 2.5. So we are given that L is equal to 10, the logarithm of I over I naught. All right, so this may be current or whatever that you're given there. Then you're asked to make I naught the subject of the formula. That is, we need to make I, but the one that has got a 0, this I naught. All right. So what can we do? This is a logarithm where we understand if the base is not given, it means we are in base of 10. And we also understand from our logarithms, I explained the conversion that can actually happen between the logarithm and the exponential. These two, they've got a great relationship. The logarithm of A in base of B, remembering that if it is equal to C like this, we can rewrite as A is equal to, so you're going to have this A is equal to the base of B raised to the exponent of C. So that's B to the exponent of C. So this is the scenario that we have, all right? But we just have to maintain or have a single logarithm. And to do that, we can simply divide by this 10 that is multiplying. We can simply divide by 10 both sides. So that means we are going to have the logarithm of I over I naught in base of 10 is equal to L over 10, like this. So as you can see, we have this scenario now of a logarithm equated to a certain term. That is the logarithm of this term in base of 10 equal to L over 10. So as we can see, we're going to have A in exponential form. So this is our A, the part representing this A. So that is our A, which is I over I naught is equal to the base to the exponent of C, which is the base B to the exponent of C. In this case, our base is 10. So that's 10 to the exponent of L over 10. All right, so we're going to have 10 to the exponent of L over 10 like this. Okay, so now we want to make this I naught the subject. Remember, the question there is to make I naught the subject. We have to this one, and it's in the denominator in this case. All right, if it was like this, that we've got a condition, maybe we've got I naught over 2 is equal to X. I just give an example here, and you want to make this the subject. You can simply multiply by 2 here, multiply by 2, this cancels, we've got I naught, which is equal to 2 times X, which is 2X. So if this was in the numerator on top of our fraction, it was going to be easier for us because we can just multiply by the what? The denominator. So how can we have an interchange of making this I naught this one to be written in the fraction on in the numerator of the fraction? So since here this is same as over 1, whatever that you do on the left-hand side has to be done on the right-hand side. So if I decide to interchange these two, I am also supposed to interchange these two. So the moment I write this as I naught over I like this, I'm supposed to have also on the right-hand side interchanged. So it's going to be 1 over 10 to the exponent of L over 10 like this. So once we have this, it's easier for us to make I naught the subject. So why? We have this in the denominator, so you can remove this just like the part that I was explaining by multiplying by I both sides. We multiply by I both sides. So this will cancel. We remain with I naught in this case, all right? So therefore, we can conclude that I naught is equal to, if we multiply by I here, this is same as I over 1. So that means it's I times 1, numerator times numerator, which is going to give us I over 1 times 10 to the exponent of L over 10 is going to just remain as 10 to the exponent of L over 10. All right, so that's it. We have got I naught as the subject of the formula, or we have managed to change whatever that we are given to have I naught on one part of the equation as the subject or as the king of the equation. That is how you might simplify these typical questions when given logarithms. You have to know this conversion taking place. That conversion, guys, is very, very important. This conversion is very, very important in your simplification between the logarithm and the exponential part. All right, so that was it. Question 2.5, 3 marks for that. All right, let us check question 2.6, which was actually a word problem in this case. All right, so let us try to see what you're given on 2.6. That was in this case 4 marks. All right, so we're given in this case 5 times the sum of two numbers is 100. All right, so let us just try and see what this is all about. Okay, so this is question 2.6. So we're given 5 times meaning to say we are multiplying 5 times the sum of two numbers is 100. All right, we do not know the numbers, so you can just say let x and y be the two numbers. Okay, be the numbers. All right, so you're going to have this as the given numbers, which is x and y. So if x and y is representing the two numbers, they're saying 5 times the sum. The sum means you are adding x plus y like this. If you add x plus y, then 5 times of this, 5 times means you are multiplying this by 5. That is twice, multiply by 2, 3 times by 3, 4 times, you multiply by 4. Whenever you're given times, it means you're going to multiply. So it's 5 times the sum. This is the sum, but it has to be multiplied by 5 in order to give us 100. So they're saying 5 times of the two numbers should give us 100. And half their difference, the difference means you are subtracting. So meaning to say we've got another statement, the difference, if we say here is the sum x plus y, meaning to say the difference is x minus y, we are subtracting. But they are saying half their difference, meaning to say if we multiply this difference by a half, just like 5 times the sum, we must obtain a certain value. 5 times half of their difference is a 5. So meaning to say half of this must be equal to 5. So these are the two equations that we have formulated or that we have. And we are going to use this to solve for the value of x and the value of y. All right, so as you can see, it's easier for us to have this x plus y as the subject. We are multiplying by 5 here, so we can simply divide by 5 both sides. So that means we're going to remain with x plus y in this case, right? So that's x plus y is equal to 5 into 100, or 100 divided by 5 is going to give us 20. So this is our simplified equation. We do the same thing here. We can just divide by 1 over 2 or multiply by 2 or just divide by 1 over 2. So that this will cancel and we remain with x minus y, which is equal to 5 divided by a half. If we divide this, we are going to obtain a 10. All right, so if we just divide like on your calculator, that's 5 divided by a half, in this case by 1 over 2. So that is going to be a 10. Remember, we changed this. Let us just go to the normal part. All right, so that's mod here. Just gonna go to the normal, which is 8, then press 2. So that's 10. So meaning to say if we divide 5 and a half, we are going to obtain a what? A 10. All right, so this is easier for us to solve as we have got these two equations. It's either you are going to work them simultaneously in the elimination method, you're going to use substitution method, it's up to you. to simplify. So here I'm just gonna take advantage, since here is x, here it's x, here it's y, here it's y. So I can even use elimination direct. It does not have hindrances in this case because we have got same coefficients in this case. All right. So I'm just gonna ask myself, what can I do to eliminate x? All right. I can think of eliminating x in this case. So it's positive x is positive x. So to eliminate x, I can simply subtract. So that's equation 1 minus equation 2, or equation 2 from equation 1. So if we are to subtract here, that is by elimination, we are going to eliminate x. X minus x, that's a 0. We have eliminated x. X is no longer part of our equation. We want to remove x. That is to eliminate x. But whatever that we have done to eliminate must be done, to eliminate this x, it must be done throughout the equation. So meaning to say we are going to subtract y minus y like this. So that's y minus y like this, which will be a positive y. So that will be 2y is equal to 20 minus a 10. So if we subtract 20 minus 10, we're going to obtain a positive 10. Then divide by 2 to obtain the value of y, which is be a 5. So thus we can substitute the value of y, or we can eliminate y here by adding. This time, since we've got different signs, that's a positive and a negative, you are going to add. Or you can just substitute the x value into any of these two equations. Remember that x plus y is equal to 20. So I can substitute the y value, which is 5. So that's x plus y being 5 is equal to 20 like this. So that's x is going to be, if we transpose 5 to that side, is going to be a negative 5. All right. 20 minus 5, which is going to give us 15 in this case. All right. So this is the x value, 15, the y value being 5. So these are the two numbers. Remember, we are supposed to obtain the two numbers that will give us these conditions that we are given. So the two numbers will be 15 and what? 15 and 5, or 5 and 15. So therefore, the two numbers, all right, the two numbers will be 5 and what? And 15. All right, so if we are to try any of these statements, it must make sense. Here they are saying the first part that we just want to see if it makes sense with these numbers that we obtained. They are saying the sum of the two numbers, 5 times the sum. Remember, our two numbers is 5 and 15. 5 and 15. So they are saying 5 times the sum. 5 times the sum. If we add this 5 plus 15, we must obtain 100. All right, 5 plus 15, that's 20. 5 times 20, which is 100. The same thing, they're saying half the difference. So that's half the difference, their difference. So it's half of, we subtract. So it's going to be bigger number, definitely minus what? The smaller number. So that's 15 minus 5, which is going to give us a difference of 10. So half of this, half of 10, it's a 5. So thus they are saying the difference is 5. So if you see, it makes sense to what we are given. So it must be the same condition from the values that you're given. You must be able to substitute those values to see if they correspond to the statement that you are given, and also in your simplification. So that was it, guys. 20 marks for this. Just have to revise as much questions as possible as you are working towards exams. These will be typical questions. Even in your final exam, this is how the questions will be given as. So you just have to revise as much questions and see how do they ask and how are you supposed to attempt those typical questions. It will be easier for us to attempt any exam or to sit for any exam that is to come. All right, guys, let us just continue to work with more question papers.